Hi, everyone. My name is Felipe, as I was just introduced. My talk is going to be about generic views and class-based views in general. I do want to start by saying thank you to all the organizers for putting on an amazing DjangoCon. It has been great. I don't know about y'all anyways, but I've had an amazing time. Oh, slide. There we go. Now we're back. Wait, no. Not back. There we go. OK. All right, so a little bit about me. I am a software engineer at UT Austin. I was actually trained there at UT because we have an amazing program to train people that have no background in technology to be software developers. If you have any questions about that, you can ask one of the many UT people that are here. And we use Django for a lot of our websites, so that is also why there are many of us here. A bit about some helpful knowledge going into my talk is just having a basic understanding of Python classes, URL routing in Django, and function-based views. Also, a little bit of forms, but that's not really vital. And then hopefully you'll walk away from this talk with an understanding of class-based views, and specifically generic class-based views within Python, or within Django, sorry. And then some pros and cons to class-based views, as well as some examples of good and bad use cases. I'll have code samples throughout my slides, and they'll be in Python 2, Django, or Python 3.7, Django 2.2. And then I also have an example repo that has some of the class-based views usage. And in there, I also have function-based views that mirror the usage, so you can kind of see what they're like, trade-offs. And they'll be labeled. The slides will be either they'll say sample if it's from this repo, or if it's from Django, it'll have the little Django icon. All right, so getting into class-based views. So first, a little bit of history. There's actually an interesting history that led to this. So one thing that we have a lot with web apps is a lot of them are just kind of CRUD. You do a lot of CRUD patterns with it, and that repeats a lot. So Django, we wanted to make something that would make it a little bit easier for us so you don't end up copy-pasting all the time. And so a solution was to do function-based generic views, which, I mean, what they did is they abstracted a bunch of logic, and you would just pass it a few arguments to the function, and it would handle it. So basically, you would maybe pass it a template name or the form that you want to use. But the problem with that is that they're limited. You can't really extend or customize them easily. So if your use case was even slightly different, you basically had to recreate the view yourself because of how functions are. So that's where we got the idea for class-based views, because Python classes are meant to provide functionality that's easy to extend and override. So then the question became, well, how do we actually implement class-based views in Django? So one of the things we need to keep in mind is how do you deploy them, how do you use them, and then how does URL resolver actually handle them? Because it won't be the same as with functions, or it could be, but that's what we'll talk about. How easy is it to subclass them and override whatever functionality you care about or need to change? And then thread safety. So you want to make sure that every request that comes in is on its own. It doesn't interact with any other request. How easy is it to test? Do you need to do anything special for when you want to test them? And how easy is it to decorate it? Because if you want to use decorators, we want to make sure that it's still easy when you switch over to class-based views. So really quickly, let's look at an example of urls.py with a function. So the second argument that you have here is a function, and we just pass it the function without calling it or anything. The URL resolver will take care of calling it with your request, and it will pass any args or kwargs that it needs or takes. And so in essence, what this thing is, the second argument is it needs to be a callable that will take in an HTTP request and will return an HTTP response. Typo there. Will return an HTTP response. And that's, in essence, what you need there. But there's a few problems when you start thinking about how classes work, because with classes, when you call them, you don't normally return something that isn't an instance of it. So yeah, so that's one thing to keep in mind. Another thing to keep in mind is Your urls.py runs when you start your server. So if you were to instantiate a class right here, that would happen when you start the server versus when every request that comes in. So that causes some issues that we'll get into a little bit. Yeah, so view instantiation and thread safety. I'm going to go over this a little bit quickly, mostly because this isn't directly the meat of my talk, or the reason for my talk. It just kind of explains some of the reasons why it looks how it does now. So one of the ideas was, or I'm going to go over some ideas of what was considered before we got where we are actually now. I actually also have a link that has the article in case you're interested in reading more in depth about all the reasons of pros and cons and all that. So one of the ideas was storing the request, or storing state on the request, because like I mentioned, if you instantiate it in the URLs, that same instance is going to be used across all your requests. So you can't really store state on the view because that'll be shared. So one of the ideas was let's just store it on the request because that gets put in fresh every time. But obviously that has some cons in that you can't store any state on the class itself, on the instance, because of the bleeding over. So that's one issue. Another idea was with call. So like basically you would put it in there, and then whenever you call the instance, it would make a shallow copy of itself. But that's also weird. Like one of the cons is that it is weird. It's not what you would expect a class to do when you call it. So that's one issue. Another one is new. So this is like just when you instantiate the class. So you would just put it basically just the class name. You wouldn't actually instantiate anywhere else. The issues with this is that you can't pass anything to in it. So like if you want to pass any arguments to it, you can't really do that easily. There's a way around that, but you'd have to go do that other thing. So that was a big con to it. So an idea was brought up to say, hey, let's define a method on a class, and this method will take care of actually creating our class-based view and handling everything as it needs to. One of the cons with this, though, was that you also cannot pass arguments to it as is. So there is a class method too. And this one, you would actually call this class method. And what this lets you do is pass arguments to it. And if you are familiar at all with class-based views or generic views, you can see that that's actually what we went with. But there's two more. So one more is HTTP response subclass. So this one's a little bit weird. So this one, the idea was that you would make a view a constructor that like creates an HTTP response. It's weird in that it makes a view and HTTP response be tied together in an object-oriented way that we kind of don't really want it to be, because we don't want view to be a response. We want view to return a response eventually. So some weird things there. And the other one, the final one, was URL resolver. So another idea was, instead of messing around with any of that, let's just make URL resolver figure it out on its own. So it'll take in it'll check when you pass it, hey, is this a class or is this a function? And if it's a class, do this special handling to set it all up and then pass it on. But that would require special handling and URL resolver, which we didn't want. And then decorators become a bit of a nightmare to actually decorate your view. So like I mentioned before, as view is the way we went. So as view, the way you use it is we just have a create to-do list view, and it's just a class-based view, and we don't instantiate it, as I mentioned before. We don't do that because it causes some issues. We call asView, and asView will handle setting everything up that we need. I'm going to go into how that is handled, but for now, just know that it sets everything up that we need, and here we'll be able to take a request and return a response. I have this diagram again just to show it, and it also has the same typo that I didn't fix on the second one. It returns a response, not a request. All right, so at this point, we now have class-based views. They work. But we want to add some functionality, so we start getting into Mixins. So the idea was that any functionality you want to add, we should do it in little bits and chunks so that you can kind of mix and match however you want. If you care only about this very specific piece, you can easily grab it without having to either recreate it or break something else apart. So Mixins were the plan, and so we would work with class-based views. Generic class-based views would be built up through inheritance. So for example, here on the top right, we have view, and that's the view, the class-based view that just enables everything. And then we have two mixins. One of them is ContextMixin, one of them is TemplateResponseMixin. And so these two add some functionality, which we'll go into later. But what we want, or what we do with it, is we combine all three, and that'll make template view. So now we have a generic class-based view that Django provides. And yeah, so let's go into a sample use case, like why would you even want to use generic class-based views, right? So just creating a new instance of a model. It's something that's very common. Here's a simple function-based view that on get will instantiate a form and then render your template with the form. It's pretty simple. And then if it's a post, we'll instantiate the form, pass it the data, and validate it. If it's valid, we save the form and then redirect. If it's not valid, we re-render the template with the form with errors, right? Really simple. This is a really short view. Doesn't really take much. But like, why would you write all that when Django provides a create view, a generic view called create view, and all you have to do is set the template name and form class. And that's it. So this already like does everything that the function-based view did. And then in your URLs, basically the way that would look is this is the function-based view. You pass it the function, right, on the second argument. And the class-based view, you just do the create to-do list view as view. And that's it. So generic class-based views are great in that they encapsulate a lot of logic that we repeat often. I'm sure you have to create instances all the time, so why would you want to repeat that type of view for all your models or something when you can just easily subclass create view? So let's get to a few pros and cons. So function-based views. Some pros, explicit code flow is like one of the biggest pros for function-based views in that with a function-based view, it's like any Python function, as you can just read it straight through and see what it's doing, assuming you wrote it cleanly. So you can see exactly what's going on. There's no wondering what happened or anything. Another one is decorators are really easy to use. Easy meaning if you know how to use decorators in Python with functions, you know how to use them with function-based views because it's the same thing. Some cons, they're hard to extend and reuse, so kind of that same issue that we had with the generic views in Django, the generic function-based views in Django, that they were hard to extend and reuse. You kind of have that same issue with your own function-based views. And the other one is HTTP methods are handled through conditionals, so that gets a little bit ugly after a while. For class-based views, though, so pros, we have all the built-in generic class-based views. Django provides a ton, and they give us a lot of functionality. And then HTTP methods are handled through methods on the class, so it's a little bit cleaner. You can just look for the method that does like if you're doing a get, you can just go straight to the get and see it, rather than reading through your function logic to figure out when do you check to see if the method's get. And then you can use object-oriented techniques, meaning you can create mixins, use inheritance to your advantage to try to like piece together what you need and make it easier for yourself. One of the cons, though, and the biggest con, is implicit code flow. So I showed you that example earlier of that create view, but if you don't actually know what create view looks like you don't know what it's doing. You're just right now taking, or unless you're familiar with it, you're taking my word for it that I'm telling you it's doing what that function-based view is doing. It's going in and instantiating the form, rendering the template, and handling on post, saving the form if needed. So that can be a little bit of an issue, especially when you're new to coding. I know when I first started, I had a lot of issues with class-based views because I never knew what was happening. And then decorators are they're not as straightforward to use in that classes are different than functions, so you need to do a few things, but thankfully Django actually provides some ways to help you with that. So it's not too bad. Yeah. And then, so getting into some actual internals. So earlier we were talking about how our base view that actually enables class-based views is this is it. It's just a class that has an attribute called HTTP method names. What these method names are basically what's allowed in the class-based view, or what methods you're allowed to pass in. This is different from what you'll handle, which I'll go into later. But yeah, and the list is cut off because it's long and would be not legible otherwise. Okay, so on init, the init's pretty simple. All it does is it loops through the quarks you pass it, and it will set attributes, or set attribute values to what you pass in. It's really simple, but really powerful in ways that I will show you later. Okay, so you might be wondering, hang on, we don't instantiate our class in the URLs. And just proving that again. Here's the class-based views in the URLs. We don't instantiate, we call asView. So the way this works is asView handles all this magic for us. So what asView does is it's a class-only method, meaning it's meant to be called from the class. And it will take init quarks, and the name init quarks basically is just telling you they are quarks for your init. And then, so what it does, we want to be careful though, so one of the first things we do is we loop through all our init quarks and audit two things. One, we don't want any init quarks to come in and try to set any methods. So we check to make sure that none of the keys are an HTTP method name. So basically, we don't want someone to try to pass like get in there. I guess you could maybe do something with Lambda or something, but I don't know. It's weird things, so just avoid it. And then the next thing is we check to make sure it's actually an attribute of the view already. So we don't want to be setting new attributes through this. It gets a little messy. I mean, if you really want to set a new method, just go define it in your view, and then you can pass it in. So just to be safe, we check that. And then after that, so now we get into the really interesting bits of asView. So asView, within its definition, starts defining a new function called view, which may look familiar. It's just a function-based view. Basically, it takes a request, args and quarks. And then the first thing it does is the first thing this view does, rather, is it instantiates our class with our init quarks. So here is where our init quarks come into play and get eventually into our class. The next thing it does is just some handling to make sure that if you haven't defined head, you kind of make head and get the same thing, because why not? And then setup. So setup is actually a pretty neat method that just got added in Django 2.2. And so what that does, we're not done with asView, but we'll go back to it right now. So what that does is it takes request args and quarks, and it sets them on your view as attributes. And what this means is that in any of your methods, you can now access them pretty easily, which is great, because then you don't have to worry about defining your method's signature to include request args and quarks and then worrying about how to get it to them. You can just know that they're there. And one of the useful things about, like, Django already did that before in Classbased, in the asView before, but now it pulled it into setup in 2.2, and what that lets you do is if there are any attributes you want to be accessible in all of your, you want accessible in any of your methods, you can set them on here and then just call super, so the default will set up the request args and quarks, and you're set. Now you have attributes you can access easily anywhere else. All right, so back to our view function that we're defining within asView. So we called setup immediately after. We have a little validation to make sure that we did actually call super if we overrode it, or super for setup if we overrode it, so we just check the request is there. And then at the end, what this view does is return, or call dispatch with request args and quarks and return what it gets back. So, so views, we'd already said earlier, they need to take an HTTP request and return a response. So what we're saying here is we're kind of passing that on to dispatch and saying like, hey, dispatch, I need you to return me a response. I'm just going to trust you, and you can do that. So now we know dispatch, which I haven't covered yet, but I will in a second, is supposed to return a response of some kind. And then after we finish defining view, we do a few things on it. So view, or functions in Python, are just any Python object, which means you can actually set attributes on them however you want. So in this case, we set view class and view init quarks in case you want to access them later for whatever reason. And then the next thing is kind of neat. So
because we're setting up this function is actually not our class-based view, obviously. But we want it to act like it, and we want it to look like it. And we've already taken care of it acting like it by returning the dispatch and all that. But now to make it look like it, we use a func tool called update wrappers, or update wrapper. And what it does is it takes this view, it takes our class, and just kind of takes like the name and the doc string and a few other dunder attributes and sets them on the function. And then the last thing is, I haven't gone over decorators really, but decorators are typically put on dispatch, and they sometimes set up attributes on the dispatch itself. So we want those too, so we do the same thing again with update wrapper, except this time we pull them from dispatch. And one example of an attribute that might be set is like CRSR if exempt. And then at the very end of asView, it returns view, as is. Like we've just defined it basically and added a few attributes on it. So what that means is here, what this all means with this class-based view is that when we're calling asView, we expect it to return view, and view is just a function at this point. And at that point, we are basically using the same thing as we used with function-based views. Final thing for view is dispatch. So dispatch is really simple. All it does is receive request args and quargs, and its job is just to figure out what is going to handle this request that just came in. So it just checks to see if the method of the request is an allowed one, so from that list earlier that I showed you. And if it isn't, it returns a 405 HTTP response not allowed. But if it is allowed, then it tries to find the handler for it. So it looks on your view and says, hey, have you defined, for example, get? And if you haven't, it once again returns HTTP method not allowed. So that's why I was saying that that list is allowed and handle, like, there's a difference between what it allows and what it can handle, and here's where that gets resolved. But if it is defined, so if you do have get on your view, then what this does is it'll take it, it'll call it with request args and quargs, and then it will return that. So dispatch is also kind of passing on the responsibility to something else for returning the HTTP response. So one thing about view is it doesn't actually define any of the typical methods that return an HTTP response. So you can't just use view and not define anything special on it. You have to define get or post or whatever you care about. It defines a few things, but if you want to do get post, it doesn't define those. Just okay, quick pause because that was a lot of information and also water. Okay. Whew. Okay, so that's a lot of stuff, and whether or not you followed. To be honest with you, like there were parts of that I didn't understand until I was preparing for this talk. Like I've been working in Django for like 4 years now, and there are parts that I was like, that's just magic, which it's not. It's actually, it's not magic. It just takes a little bit to understand. But yeah, but it's pretty cool, and it'll set us up to do some really cool things, making our lives easier. At least it can. So Django provides a lot of generic views. And like I was mentioning earlier, the way that works is Django's point of view is we provided class-based views through view. Now we're going to provide some generic class-based views that you can use to do things. But the way we want to do that is we want to provide a bunch of mixins. And those mixins will each do something, like a little bit of functionality that builds up to whatever great thing you are doing with your website. So the most basic one is ContextMixin. So when we normally render our templates, we pass it some type of context. That's how we pass it the variables that we care about, right? And so what ContextMixin is, it's kind of meant to do that for class-based views. And it defines just one attribute, extra context, and defaults it to none. And I'll go into that right now. And it only defines one method. This method is GetContextData, and what it does is it takes whatever quargs you pass it, and it adds in view. So it adds itself in, which is kind of neat because then that means that you can easily access any attribute of the view in the template. So like if you want to look at your user, you can easily do view.request.user. Or you could access any of the quargs that the view was, that was in the request for the view. So yeah, so that's pretty neat. And then the other thing it does is it takes extra context, and if it's been defined, so like if you, in any of your methods, actually defined it beyond none, it will update the quarks with it. The intention for that was kind of to make it so that, kind of how I talked earlier about how you can pass things to asView, and it will eventually make it to init, which will then set it as an attribute, or set the value of the attribute. This means you can kind of take it in your urls.py, you could pass context to the template directly. Don't know if you want to do that. But what I like about this is that in any of your other methods, if you want to put anything into the template context easily, this is how you could do it. You could just access extra context. Just create the dictionary or add to it if you've already created it. And then you don't have to worry about it. GetContextData will eventually put it into the context that hopefully makes its way to your template. So yeah. And then the next one is TemplateResponseMixin. So this one defines a few attributes. I'm not going to go over all of them. The most important one is template name. Just point it at the template that you care about. And then its important method that it defines a few, but the most important one is render to response. So this one takes care of, as you can see at the top, it takes in context and a few other things, but context is the important one. So it takes in context and it renders your template that you've told it, that you've given it the name. It renders your template with your context. And so this is actually the portion that returns the HTTP response because it's rendering your template. So going to our first generic class-based view, what this is TemplateView. So it takes in those two, or it combines those two mixins and that view, the base view, and all it does on top of that is, like I mentioned, none of those other ones actually define get. So this one is like, all right, I'll define get, and then I'll use GetContextData to get my context, and then I'll pass it to render to response, and I'm done. So this is literally all of TemplateView right here. It's really simple, and that's kind of the point of doing Mixins too, is to let your final views like just do the thing that they need to do once they've combined all the functionality. So, for example, here's TemplateView. Here's a template view for home. I just define template name, and that's it. There's another way you could do this, though. You don't even have to define it in your views.py. Because of the fact that you can take advantage of the fact that asView will pass attributes on, you can set template view in your urls.py and do a home page like this. Whether or not you like to do that is up to you, but I mean, I think this is pretty nice if it's a simple home page that doesn't need anything else. The next one up is redirect view. So this one provides a few things, the important ones being URL or pattern name, and it does exactly what it says. It's just redirects. It's really quick and easy. And so, for example, one thing that you could think of is, say you have a website, a URL that's show all lists, and then your client says, hey, you know what, instead of show all lists, I want to rename the URL to say list to do lists, for whatever reason. An easy way to do that is using redirect view. You can create your new path, put the old view there, and then in the old path, you can just set redirect as view, and then pass it the pattern name to your new, or to your new URL, and you're set. Although you should, yeah. Okay. And the next one up is ListView. So this one's just what it says. It's another easy thing that we tend to do very often is just listing out a bunch of data. So it's really easy to set up. Just set a few attributes. One of the things that's cool about it is kind of sets you up to be able to paginate through data. So if you have a lot of data, it makes it pretty easy to do that. One downside is it doesn't set up an easy way to filter your data. So if you need to filter it at all, yeah. I will show you an example, though, of how you can filter it. So here we have two URLs. They both lead to the same list to-do list. I should have chosen different names. List to-do list view. One of them is just straight to the URL. The other one captures name search. And the view itself, my subclass, is just, or it could just be ListView, setting the model, and the template name. If I didn't want to do filtering, that'd be it, which is really nice. They would then go and list all my instances of to-do list model. If I wanted to do pagination, I'd have to set up a few attributes here, but that'd be it, just kind of telling it how many per page and a few other things like that.
But since I want to do filtering, we need to do a little bit more. So one of the methods that it defines, that ListView defines, is GetQuerySet. And so that's what it uses to go and get all of your model instances. And so what I did here is I just let super do its thing and return all the instances. And then I just check to see if I need to actually filter it. So here I'm taking advantage of the fact that kwargs was set as a self-attribute, meaning I don't actually receive kwargs in GetQuerySet, but I can easily access it. And then if I need to, I filter the query set and then return it. If not, I just return the full query set. So it's not set up to easily do filtering, like through attributes or anything, but you can, it's pretty simple to set up just overriding GetQuerySet. Okay. Another one is DetailView. So DetailView lets us just put out the details of some model instance. It's really simple. It's kind of basically it's implemented in a similar way to ListView, except focusing on a single item. And so this one, same thing. It kind of just needs the template name and the model. I took it a little bit further and added another attribute. So by default, DetailView sets your instance into the template context just as object, which I find weird. It makes sense, like for being a generic view, but if you want it to actually make more contextual sense in your template, you can give it a name, and so that's why you can set context object name. So like I just said, this is going to be a to-do list. So it's up to you, though. You can just use object if you like that. But you might be wondering, hang on, how does it actually know what instance we want the details for? Because I didn't actually define anything here. I just said, hey, here's my detail view. Go figure it out and get something. So the way it does it is through the URL. And in the URL, we capture the integer pk and call it pk. And then it'll pass it as a kwarg. And the reason this works is because one of the mixins that goes into making this sets up something called pk URL kwarg, which is the second to last one on that list. And it defaults it to pk. So it's just, I just went with that name. If you really care and want to change it to something else like ID, you can. And that's all you have to do is in your URL capture ID instead, and here change this attribute to ID. So pretty simple. Form view is the next one. So now we're actually getting into being able to do stuff beyond just listing things or showing data. So form view lets us actually render a form and process the form once it gets submitted. And so the way, sorry, I realized I forgot to mention one thing earlier. So I was talking about how the way all this works is we have mixins and combine them with views, and Django, to create its generic views, actually takes those mixins and makes other mixins. So like context mixin gets subclassed and added, functionality gets added, and then like TemplateResponseMixin also gets subclassed and functionality gets added. So that's why like here on form view, we don't have either of those. We have template response. Oh wait, no, that is the same one. Sorry, that's the wrong thing. Sorry, I'm all over the place. But base form view is basically the same thing. Base form view is view mixed in with other things that kind of eventually makes it to something called base form view, and then form view just takes that and combines it with TemplateResponseMixin. But there are other mixins that just are pure mixins, and when the next one comes up, I will point that out. All right, so one thing about this, though, is that form view is designed to only handle post submissions, which is not ideal for everything. So if you have a get form, you need to do a little bit different stuff, but I'll show an example of doing that. So form handling. So if you want to set up, or what it does for us is it sets up this method called getForm. And what it does is it takes a form class and it instantiates it and passes it a bunch of kwargs through a method called getFormKwargs. And it eventually will make its way to the template just as form, which is typically enough or fine. And then on post, it will, by default, get the form, instantiate it using that same get form. So get and post use the same thing to instantiate it, and then the get form kwargs is the one that actually handles whether or not there's data. And then it validates it and then returns self-valid or self
invalid or self-form invalid. And then, so basically what we're saying, what those do is just return some type of response because we're in the post and we need to return some type of form response. So if you want to use it, you can easily subclass it and just set a form class and template name, and you'd be set. I took it a step further here, though, and I was like, I want to make a form that handles a get form, or get submission. So I kind of limited the HTTP method names to get and options. And so I need to do a little bit more now. So now on get, I check to see if it was a get submission, and if it was, I instantiate the form, validate it, and then return form is valid or form invalid. And then if not, it is cut off. But if not, I just return super, which will just render the form on the template brand new. And so another change is on get form quargs. So earlier I didn't show get form quargs because it's pretty simple. All it kind of does is set up like initial, prefix, and data. But like I mentioned, it only does data for post submissions. So the reason we need to change it here is just to be able to set data from a get submission. So here we check, hey, was it a get submission? If so, let's set it in the quargs and then return that. And then the final thing that we need to do is just set up what happens on form valid. You don't really need to do it here. You could also just set a success URL, but here what I would do is, because I want to redirect based on the actual form data, I just define form valid and pull the form data out and redirect accordingly. Okay, so create view. Create view is, well, actually, I already showed you create view, but create view, as I showed you earlier, is a really simple way of just creating new model instances. This actually does have an example of a mixin that was made up of other mixins. So single object template response mixin took another mixin, did stuff to it, and let us add a functionality. Yeah. Okay, so update view is really similar to create view. Honestly, it is so similar that I'm not going to show you an example of using it because it's basically the same thing. The only difference is it just, on the first pass-through, will instantiate the form with the instance that you're working with. So it's pretty neat, but simple. Delete view. So this is the last generic view that I'm going to go over. And so this one is actually, interestingly, more like detail view than create or update view in that it will, actually you can see down here, it subclasses base detail view at one point. And all it does is add a post handler for deleting the instance. Yeah. One weird thing about it is the fact that it does it on post, though, not delete. Yeah, so there's a lot more. It can be kind of hard to keep track of everything that they do. One term that I heard recently to describe them was ravioli code, in that you know that they're good. They can be really great, but you don't really know what's in them until you go and dig in there. From the outside, it's just like, this is a nice little neat package that provides something for me. So to that end, there's this website called, that's called Class-Based Views, and it's ccbv.co.uk. And it's really neat. It lays out all the class-based views that Django provides, and you can see easy examples of how everything got put together. So it'll show you, let's see, okay. I was supposed to do screenshots, but I didn't do the screenshots, and let's see if this actually works. If not, I'll just go back to the presentation. I can't zoom in, though, because I can't see anything.
Control plus.
Okay. Oh, there we go. Okay, zoomed in a little bit too much. But yeah, so it defines all of the views. And so, for example, you can go to ListView. Did I actually click? I did. Cool. And it tells you where they came from. So it'll show you all the attributes and show you, hey, this attribute came from this mixin or this view. And then if you scroll farther down, it'll show you all the methods and tell you where those came from. So on the side, you can see. And then if there's one that came from multiple, it'll show you what each of those defined. So it's a really useful site. I honestly have it open all the time when I'm working with class-based views because I forget what class-based views defined things, or like how things flow exactly. So it's really useful. Yeah. Oh, man. What did I do? Hang on. Shouldn't have done that, I guess. This is why people told me to not do that. It's loading. There we go. OK, cool. We're back. Probably. OK. So you might be asking yourself, all right, you showed me tons of views, and there are many more. Like I said, I didn't go through. I probably went through like maybe a third of them. So there's tons of them. Which one should I use? And so some guidelines that I kind of try to follow is that if there's one that basically does everything that you need, so like create view, did everything I needed for for that example, just use it. I mean, why would you want to go define the code that does the exact same thing? And then if later your needs change and you need to do more, then you can just change it out. It's not like you invested that much in just using it and setting a few attributes. And then if you're, oh, I think I deleted one. Oh, OK. I switched the slide order accidentally. OK. So if there's one that you just need to extend and override a few parts, so like, for example, my list view, I wanted to filter the query set, but that was just one method that I had to override, and even then, it wasn't even that much code that I changed on there, then just use that. It's more when you get into, like, when you start overriding a lot of stuff that it kind of becomes, it kind of ruins the point of using a generic view, and it gets really hard to keep track of what you're doing because you're kind of overriding this bit over here and then this bit over here, and it's like, wait, but how do those two interact now? And so keeping track of all that is a mess. So what I would say at that point is just use view or template view, because those, like, view is just setting you up to be able to use class-based views, and template view is a generic view, but it's a very basic generic view that just kind of provides some template loading functionality. So I'd say start with those and build your way up. I actually know people that hate most generic class-based views, but they like class-based views in general, like the idea of them. So they use view or template view as their base class every time, and then just write everything else on their own. OK. Creating your own view. So I'm going to go through this a little bit fast because I only have a few minutes left. Yeah. OK. So why should you make one? So this kind of Mixins. Click on something. OK, Mixins kind of provide encapsulate some of the logic that you need to repeat across your views, and so that's kind of the same reason why you would want to use class-based views, so that you can take advantage of those mixins. Especially, you can take advantage of the pre-existing mixins, but you can also make your own mixins if you need to repeat something across all of your views. So, for example, you have like an authorization type thing that you want to use in all your views. One way to do that is make a mixin and then just add it to all your views, and that handles it pretty easily. So creating your own, I would say that if you can create like a base view if you find yourself using the same thing over and over again. And if you can either create a base view or you can create a mixin. It kind of depends on what you're doing. So like if you're doing the same, like everything of that view is basically the same, you're just setting a few different attributes, then yeah, create a class-based view that's like a base class-based view for you. If you are doing more like I was mentioning, the authorization bit, where it's just a bit of added functionality on top of everything else you're doing that's different in each view, then do a mixin. So when I first started, I had to deal a lot with pages where my users wanted to have like 6 or 7 forms on the page. And at the time, it was really annoying that in every view, I was defining every time like how to handle all those forms, especially because like the forms themselves were they were different, but they were handled similarly. So I was like, you know what? I'm going to write a class-based view that handles multiple form submissions, like rendering multiple forms and handles multiple form submissions. And it worked it worked great for me. Like, I was like, oh, this is amazing. All I have to do is like set a few attributes, and it works. But then like 6 months later, I had to go back to it, and I was like, what am I even reading? Like, I don't understand what I did. Like, I was because I needed to add another form and like take out one of the previous forms, and it was just a mess. It was so hard to read. Someone else had to then go back after me and do the same thing, and they also like were like, I don't know what is happening. I'm just gonna like cut in right here and kind of stick my code in, and it works now, kind of, but not really. So make sure that if you are going to create your own base classes, you do think it through. Make sure that you're not doing anything too complex in your base classes, because if you're doing a lot of complex logic, it might be better to just handle it in that specific view and save everything else in your code base from it. Or, you know, break it up into like separate views. It's not like you have to do all of that in one view. I am not going to show the code because it is very long and a mess, and getting it to show properly on here would be horrible. But it is in that repo, in case you're curious. If you want to go read it, I have a lot of documentation on it, which was good, I guess, because I could then figure it out, but I had to sit for like half an hour to figure out how to add a new form. Okay, so an example of a possibly good class-based view to do is, one thing we do a lot is we have a lot of cases where our users need to search through a bunch of our data and then like list out a bunch of attributes for that data, but then they might not need to keep filtering the list. And so we actually decided to create a combination of like a form view and a list view, because we found that we were either starting with form view and adding all the functionality that list view added, or starting with list view and adding all the form view functionality. So we created a class that does that. And that is also linked in here. I'm also not going to show it because it's much simpler and cleaner than the other view, but it's still wordier than what would be nice to show on these screens. Okay, so just really quick to kind of finish up. We covered intro to class-based views, so I kind of explained how we got to where we are. And like I said, I linked the article if you're interested in reading more in detail what happened. I went over some pros and cons. I went over the internals, which was a little bit, I mean, I guess it's the intention of today, right? Deep dive. Yeah, if you have any questions about that, you can ask me later. And then I talked about some of the generic views that I think are pretty useful, and at least they can be really useful. So if you find uses, you might as well stick them in. I have a bunch of resources. And one thing before I finish. There are more slides, actually. My talk was really long. I can talk for a really long time. So I actually have a few more slides on like mixins and decorators. So if you're curious, you can look at those slides later, which are like, you know, just going past the end of the current end. Just wanted to let you know, so if you want to look at those. But yeah, so that's it for me. Thank you, everyone.